Welcome to Lesson 3-6, Proving Angle Relationships. By the end of this lesson, you should be able to prove theorems about angles. So let's learn a few things. We're going to talk about angle addition. A protractor is used to measure angles. The protractor postulate illustrates the relationship between angle measures and real numbers. You will use these theorems and postulates to find angle measures. The protractor postulate says that every angle has a measure that is between 0 degrees and 180 degrees. The next postulate is our angle addition postulate. It is much like our segment addition postulate. So if point D is in the interior of angle ABC, as we see here, point D is in the interior of angle ABC, if and only if the measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. So in other words, if the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3, the entire angle there. Our supplements theorem states if two angles form a linear pair, then they are supplementary angles. And I drew an illustration here. So here we have a straight line, right? And I have divided that into two separate angles. And so here, so in that straight angle, we've divided into two. So angle 1 and angle 2 make up a linear pair. So if two angles form a linear pair, then they are supplementary angles. So if you remember us saying earlier that all linear pairs are supplementary. And so our complements theorem says if the non-common sides of two adjacent angles form a right angle, then the angles are complementary. Now, I'm moving forward, but I want to say that I really do recommend and require you to go ahead and copy those postulates down. So if you need to rewind the video, be sure you copy those postulates down. I will provide you a handout in class with the postulates, but you need to study them. Add them to a Quizlet. So complement and supplements theorem. So here's an example of those complement and supplements theorems. So this is a shelving problem. Maylin is installing shelves in her room. One of the brackets she chose for her shelves is shown. If the measure of angle 3 is 55 degrees, what is the measure of angle 4? So here is the measure of angle 3 right here, and they're saying that that is 55 degrees. So the question is, what is the measure of angle 4? This one here. What I can see from these two is that the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. That is our supplements theorem. And so how do I find the measure of angle 4? Well, I substitute the value in for the measure of angle 3, which is 55. And so I'm using the substitution property of equality. And the next step to find the measure of angle 4 is to subtract 55 from each side. So that was the subtraction property of equality, gave me that the measure of angle 4 equals 125 degrees. Now you try this example to check. Pause the video, work the problem out, and then come back. So a city planner is designing an entrance ramp for a freeway. In the diagram, the measure of angle ACD equals 45 degrees. That's here. What is the measure of angle BCA? Show your calculations and justify your answers. So here is BCA. I'm just going to mark it with 2 so it appears different. So let's take a look. What do we know? The measure of angle ACD plus the measure of angle BCA equals 180 degrees. That is the supplements theorem. Now, we're substituting the value of 45 degrees in for the measure of angle ACD using the substitution property of equality. And then we're going to subtract 45 from each side using the subtraction property of equality. So the measure of angle BCA equals 135 degrees. So let's learn a little bit more. Congruent angles, the properties of algebra that apply to the congruence of segments and the equality of their measures also holds true for the congruence of angles and their equality of their measures. So let's look at the properties of angle congruence. We previously learned the reflexive property of congruence when it referred to segments, symmetric property of congruence when referred to segments, and the transitive property of congruence. Those same things apply. So the angle 1 is congruent to angle 1, so any angle is congruent to itself as any segment is congruent to itself. The symmetric property of congruence states that if the measure of angle 1, I'm sorry, not if the measure, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. So we can flip the way we write it. And the transitive property of congruence says if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. Looking at our congruent supplements theorem, angles supplementary to the same angle or to two angles are congruent. Um, if the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180, then the measures of angle 1 is congruent to angle 3. Angle 1 has to be congruent to angle 3. So the abbreviation angles supplement to same angle or congruent angles are congruent. All right, let's take a look. The next one is at the congruent complements theorem. Angles complementary to the same angle or to congruent angles are congruent. So if the measure of angle 4 plus the measure of angle 5 equals 90, and the measure of angle 5 plus the measure of angle 6 equals 90, then the measure of angle 4 plus the measure of angle 6 are congruent. So they're equal. So the two angles are congruent. So if angle 5 is 70, then both 4 and 6 have to be 20 because 4 plus 5 equals 90 and 5 plus 6 equals 90. And then our vertical angles theorem. Even though we're just approaching it here, we've been discussing it all along. If two angles are vertical, then they are congruent. And we had said earlier in class that all vertical angles are congruent. So angles 1 and angle 3 are congruent. 1 and 3 are congruent. Angles 2 and angle 4 are congruent. They are vertical angles formed by two intersecting lines. Let's look at example 3. In the figure, angle ABE and angle DBC are right angles. Write a proof. It says given angle ABE and angle DBC are right angles, prove that angle ABD is congruent to angle EBC. I'm going to say it time and time again. The first line is almost always going to be your given. Now, they gave it to you here, so we know that this is given. The measure of angle ABE equals 90 and the measure of angle DBC equals 90. Well, how do we know that? How do we know that they are 90 degrees? Well, that's by the definition of congruence. Because they told us that they were what? Both right angles, and we know that right angles are congruent. I would almost, even though this is what the textbook uses, I would say this is the definition of right angles. I would almost want to scratch that and say this is the definition of terrible handwriting, right angles, because that means that they have a measure that's equal to terrible handwriting. So sorry. Equal to 90 degrees. Now, number 3 says the measure of angle ABD and the measure and angle DBE are complementary. That's through our complements theorem. So angle ABD and DBE are complementary. Angle DBE and EBC are complementary. That is from our complements theorem. So how can we say that angle ABD and angle EBC are congruent? By the congruent complements theorem. If they are complementary to the same angle, then we can say that the by the congruent complements theorem that they are congruent. Now, you take a minute and try this one. Complete the paragraph proof. Remember, when they assess you on this, they're likely going to give you some fill in the blanks, so parts of it will be completed. Pause the video and try it on your own. Okay, so it says given angle 1 and angle 3 are supplementary angles, prove that the measure of angle 2 is congruent to the measure of angle 3. So it is given that angles 1 and 3 are supplementary. By the definition of a linear pair, angle 1 and angle 2 form a linear pair. So by the supplementary theorems, angle 1 and angle 2 are supplementary. Thus, angle 2 is congruent to angle 3 by the congruent supplements theorem. Hope you had that one correct. Let's look at example 4. It says given angle 1 is congruent to angle 2, prove that angle 3 is congruent to angle 4. Again, the first line almost always you're given. If you're given that angle 1 is congruent to angle 2, and now we have angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4. Well, how is that possible? Because all vertical angles are congruent. So that is the vertical angles theorem. And then angle 3 is congruent to angle 1. How do we know that this is true? Because of the angles angle 3 is congruent to angle 1 by the symmetric property of congruence. Do you see right above? Angle 1 is congruent to 3. We'd already said that they were vertical angles. So how do we flip this around? It's a symmetric property of congruence. Next, line 4, even though it's kind of off, goes to the transitive property. Angle 3 is congruent to angle 2. Well, how is this so? Because angle 3 is congruent to angle 1 and angle 1 is congruent to angle 2, so therefore angle 3 is congruent to angle 2 through the transitive property of congruence. Then how do we get to 5? Angle 3 is congruent to angle 4. Well, we take a look above. Angle 2, is there any way that we can say angle 2 and angle 4 are the same? Yes, there it appears there. Angle 2 is congruent to angle 4. So we can substitute angle 2 with angle 4, and we have the transitive property of congruence. Guys, a large part of being able to solve or to write proofs is to recognize what has happened prior to. Use those reasons, those postulates and theorems and definitions to help you decide what has happened. So take a moment, fill this one out on your own, give it a shot. Use the theorems that you've written down, because you wrote them down from the beginning, to help you fill in the blanks. Pause the video and try it out. Okay, so it says complete the two-column proof. Two intersecting lines determine a plane. Given angle 4 is congruent to angle 7, prove that angle 5 is congruent to angle 6. So number 1, of course, the first is given. Angle 4 is congruent to angle 7. Then how can we say in line 2 that angle 5 is congruent to angle 4 and angle 7 is congruent to 6? It's because those are vertical angles. So it's the vertical angles theorem. So now how can we say 5 is congruent to 7? Well, that is the transitive property of congruence. Angle 5 is congruent to angle 4. Angle 4 is congruent to angle 7. So therefore angle 5 is also congruent to angle 7. Then how can we say that angle 5 is congruent to angle 6? Well, that's also through the transitive property of congruence. We have said that angle 5 is congruent to 7, and now we're saying before that we said angle 7 is congruent to angle 6. So therefore angle 5 is congruent to angle 6. So you've just proved that angle 5 is congruent to angle 6. Let's learn a little bit about the right angle theorems. Again, write these down. You can prove the following theorems about right angles using what you already know about angle measures. Perpendicular lines intersect to form four right angles. The next one, Theorem 3.10, all right angles are congruent. Theorem 3.11, perpendicular lines form congruent adjacent angles. Let's use those to help us solve. We have two more. If two angles are congruent and supplementary, then each angle is a right angle. If two angles form a linear pair, then they are right angles. So if two congruent angles form a linear pair, then they are both right angles. So let's look at this example. Angle 1 is congruent to, given angle 1 is congruent to angle 4, prove that angles 1 and 2 are right angles. So again, you're given the beginning. Angle 1 is congruent to angle 4. How do we know 2 and 4 are congruent? Through the vertical angles theorem. And then how can we say angle 4 is congruent to angle 2? Well, that should be the symmetric property of congruence. We've taken what was written here and we flipped it around. And so they're telling us we can say angle 1 is congruent to angle 2 through the transitive property of congruence. That's because we said angle 1 is congruent to 4, and then 4 is congruent to 2, so therefore 1 is congruent to 2. Now on to line 5. How can we say angle 1 and angle 2 form a linear pair? That is through the definition of a linear pair. And how can we say angles 1 and 2 are right angles? Because if two congruent angles form a linear pair, then they are right angles. Be sure that you go back and write down the postulates and theorems that we've discussed in this lesson. Let's look at the next one. You're going to try it on your own and then you're going to pause the video and then come back. Okay, complete the two-column proof. Two intersecting lines determine a plane. Given that line J and K are perpendicular and you're given angle 1 is congruent to angle 4, prove that angle 2 is congruent to angle 4. So lines J and K are perpendicular, that is given. Then angle 2 is congruent to angle 1. How is that possible? Because perpendicular lines form congruent adjacent angles, and angles 1 and 2 are adjacent. They share a common vertex and a common side. The line 3 says given, so that has to be the second half of our given, which is angle 1 is congruent to angle 4. The last line says angle 2 is congruent to angle 4, and that is through the transitive property of congruence. Angle 2 is congruent to angle 1, angle 1 is congruent to angle 4, therefore angle 2 is congruent to angle 4. Hopefully you had that correct. Try the mini assessment, and when we come back to class, we'll try them. Then, of course, the next thing we're going to work on is our McGraw-Hill. We're on 2-6 assignment. And that is assignment, and we'll likely complete it in class.